Yes, hello everyone. So today we are discussing a question on projectile motion, and that also you can see on a wedge. So this will be consisting of a normal projectile motion plus a projectile motion on inclined plane. Both would be included here. So let us discuss the question first. It says that there is a large wedge placed on a horizontal surface with its inclined face making an angle of 37 degree to the horizontal. A particle is projected vertically upward direction with a velocity of u, that is 6.5 meter per second, from a point O on the inclined surface. At the instant the particle is projected, the wedge begins to move horizontally with a constant acceleration of 4 meter per second square. At what distance from O will the particle hit the inclined surface if two cases? Direction of A is along the BC and direction of A is along the AB. So two cases we are having. So first we have to understand, this is a diagram given in the question. The particle is projecting from here, how? Vertically. So that means the particle would be moving vertically upwards, and two acceleration cases are there. One, acceleration happening along BC, and second case, acceleration happening along AB. So let us discuss the first case. If you throw the particle vertically upwards from here, right, the particle will be moving up vertically like this, and at the same moment you are moving the inclined plane also, you're accelerating the inclined plane. Which direction? Along BC. Let us say this direction. This is a direction of acceleration, that is 4 meter per second square, and this is the velocity that you are giving to the particle, which is 6.5 meter per second. Now, solving this question with respect to ground reference frame is kind of tricky, because actually the wedge is moving and the particle is going vertically up, then it is coming down. It's okay, we can solve it. Actually, you can just find out in how much time the particle will be coming down, because particle would be doing vertical motion. So in how much time the particle would be coming down, you can find out pretty easily. In that much time, how much the wedge has moved to the left side, you can find, because wedge is starting with the velocity of u 0, correct? The wedge started with an initial velocity of 0, and then the wedge is moving to the left side with an acceleration of 4 meter per second square. So because of that, you will be able to find out the distance covered by the wedge towards the left side in the time when the ball has returned back to the same position. So by using that time, you will be able to find out how much distance the O has traveled on the wedge. I hope you understand, right? Because the point O, the particle is only performing vertical motion. It is a wedge which is moving. So if you can find out how much distance the wedge has moved by the time the particle returns, it is pretty easy. Actually, you can find out the distance covered. So, but I would go in a different approach. I'll consider an observer to be placed on the inclined plane. The observer is on the inclined plane. Let us be clear. The observer is on the inclined plane like this. So with respect to inclined plane is what I am going to do. So everything I would like with respect to inclined plane. So first of all, what is the velocity, initial velocity of my particle with respect to the wedge, the inclined plane? So I can write it as velocity of particle minus velocity of wedge. All these things I'm talking initially. Initially, what is the velocity of the wedge? It's 0. So I'm basically having velocity of my particle with respect to wedge as simply velocity of the particle, which is 6.5 meter per second, and I'm considering vertically up direction as the y-axis, so j cap. Okay, now what is acceleration of the particle with respect to wedge? So that can be written as acceleration of particle minus acceleration of wedge. Now what is acceleration of particle? Particle is experiencing acceleration in vertical direction because of what? Gravity. So I can say acceleration of particle is nothing but minus g j cap, because downward direction, and minus of acceleration of wedge. See, wedge is accelerating towards the left side. I'm considering right hand side direction as x-axis. I'll show you here. Right hand side direction as x-axis and the upward direction as y-axis. So based on that, I can write it as minus 4 I cap. And from here, I'm getting acceleration of particle with respect to the wedge is equal to 4 I cap minus g j cap. G, you can assume it as 10. So you can put this value as 10 j cap. Okay, so this is acceleration of the particle with respect to wedge. Now final step, I am interested in finding what type of motion the particle would be doing with respect to the wedge. So with respect to wedge, I will not be seeing this acceleration. Acceleration is actually happening to the wedge. But if you ask me, I will say that the particle is actually performing this kind of a motion. This is what I will see as an observer on the wedge. The particle is performing a projectile motion on the wedge. So for me, the wedge is stationary, the particle is somehow moving in a projectile. And now with what acceleration the particle is moving? With this acceleration. So first step, because I want to find out what this distance, right? Finally the particle is coming and landing at O dash. I am interested in finding the range of the projectile. Range of a projectile is always found by using the horizontal component of velocity. Initially, my particle has no horizontal component of velocity with respect to wedge, but eventually it will have. Why? Because my particle is having an acceleration in the x direction. So in x direction, the velocity of the particle will keep increasing and it will continue to have a velocity in the horizontal direction in x direction. So for finding range, I will be requiring how much time the particle is flying. So let us first find out the time. So find the time, we can directly use the formula that we have learned, that time of flight is equals to 2u sine theta by g. But sine theta value, look at it. This is my velocity vector initial. It is in j cap direction. That means it's vertical. That sine theta would become anyway 1 because theta equal to 90. So from here, I'll be able to get the time. How much will be the time value? So I'll get t is equals to 2 into u. With what speed I'm throwing? 6.5 divided by 10. So this comes out to be 13, right? 13 by 10, 1.3 second. So for 1.3 seconds, the particle would be flying. That is time of flight. For the same 1.3 seconds, the particle would be also covering the horizontal distance with acceleration. And because of that, if I want to find out the distance covered with time, I will have to use the formula S is equals to ut plus half at square. The good thing is ut, initially what was a horizontal velocity component? Horizontally, initial velocity was 0. So that is gone. And this S becomes the range the moment I substitute the acceleration as how much in the x direction? 4. And the time taken, I'm putting it as 1.3 square. That's it. So how much is the range that I'm able to get from here? 8 into 2 into 1.3 square would be 1.69. So I'll be able to get this value as 8, 18, 12, 3, 3.38 meters. This is what I'm getting. This is the first part. Let me check the question once again. They're asking what in this question? So they have asked us to find out at what distance from point O will the particle hit the inclined surface when the direction of A is along BC. So that part is done. When the direction of A acceleration is along BC like this, in that case the range, that is where it will hit on the inclined plane, comes out to be 3.38 meters. Now question is not over. They are interested in the next part where the direction of A is along AB. Now this is the interesting part. If acceleration is along AB, imagine that this wedge is moving now in this direction, okay, with an acceleration. How much acceleration? Same acceleration. How much? 4 meter per second square. If the wedge moves in this direction with an acceleration, then as the particle moves vertically upward, it will also do a motion in this way, and the particle will fall somewhere on the inclined plane at that point. The particle will be doing this kind of a motion. So can I say the particle is doing a projectile motion on an inclined plane? And it becomes very difficult to understand all the components from this orientation. So I will be now looking at this inclined plane from here. As an observer, I'll be looking at the inclined plane from here, the wedge from here, and I'll draw that diagram like this. This is how my wedge is making an angle of 37 degree. My projectile has started its journey from here in vertical direction with a velocity of 6.5 meter per second. Okay, this is the vertical that this is the direction of the particle in vertical direction. Now in projectile motion in the inclined plane, always we divide this velocity into two components: one perpendicular to the inclined plane, that is a wedge perpendicular to a wedge, and another parallel to the wedge. So if this angle is 37 and if I extend this direction downward, I find that this is 90 degree, this angle would be 53. Okay, so the remaining angle would be 37, so this will again come out to be 37. If that is 37, then this component will come out to be 6.5 cos 37, and cos 37 would be 4 by 5. Okay, so this will come out to be 1.3 into 4, 2 and 5.2. So I'll be getting the answer as 5.2 meter per second as the velocity in this vertical direction. And also if I require, I will be able to find out the velocity in this direction as the sine theta component, that is 6.5 into 6.5 into 3 by 5. 3 by 5. So again, that will be coming out as 1.3 into 3 will come out to be 3.9 meter per second. That is the velocity along the wedge direction in this way. Okay, fine. Now what about the acceleration? Again the same thing. If I try to write the acceleration equation with respect to wedge, I'll find that my body is having two acceleration. One acceleration due to gravity along the vertical direction, another acceleration due to the wedge motion in horizontal direction. So I'm going to directly draw that acceleration here. So my body is experiencing one acceleration in this direction, that is g, another acceleration in this direction, that is the a, which is how much? G is equal to 10 and a is coming out to be 4. This is my a. Like this, two accelerations are there, right? Now here also we are interested in finding where the body, the particle, would be hitting that inclined plane. So particle starts like this, and because of the motion of the wedge, the particle would be doing a projectile motion and it will be hitting somewhere here at point O dash. This point is O, like this. Okay, now again we have to find out the range, but for finding range, first we have to find out what? The time of flight. And on an inclined plane projection, time of flight can be obtained by the vertical velocity. Which vertical? The velocity which is perpendicular to the inclined plane, which is 5.2 meter per second. We can use that velocity is responsible for the time of flight. Okay, so we can say that time of flight is equals to 2 into u cos theta, that is this one, 5.2, divided by the acceleration. Now this is very important. That particle is having what acceleration in this direction? That particle, see, this is 37, this is 53, this will be again 37. So that particle would be having an acceleration in this direction, which is nothing but g cos 37 plus this would be also 37. So a sine 37. So basically 10 into 4 by 5 plus acceleration is 4 into 3 by 5. So this will come out 40 plus 12, which comes out to be 52 by 5 meter per second square. This is the acceleration that is happening along this line, that is along this line, that is velocity direction, and this acceleration are in opposite direction. So I'll be writing my acceleration as this value, that is g cos 37 plus a sine 37. This is the acceleration along that direction. So from there I'll be getting 2 into u cos 37 already found out to be as 5.2 divided by acceleration came out to be 52 by 5. This 5 can go up, it will become finally 1 second if I'm not wrong. 5 will go up, 5 into 2 10, and there'll be a 10 in the denominator. Because of 5.2 they get cancelled. I'll be getting 1 second. So that means for 1 second the particle is actually flying in this projectile. Now time I know, using the time I'll be able to find out that range. What is the range in my diagram? Isn't this the range? This distance is basically the range, but this distance, right? This is the distance. This is the range. But it will be difficult for me to find the range along the inclined plane. The easiest step I'll choose, I will try to drop perpendicular from here down, and I feel like finding this distance in horizontal direction would be much more easier for me. It is much more easier. Why? Because in that direction there is only one acceleration horizontal, that is 4. So finding that distance is pretty easy by using the formula S is equal to ut plus half at square. And what is the velocity of the particle in that direction horizontally initially? Initially, the particle was moving only in vertical direction with 6.5, no horizontal velocity. So this is anyway 0. The distance covered in the horizontal direction, I'm calling it as d, is equal to half into the acceleration in that direction is nothing but 4 into time just now calculated 1 square. This comes out to be 2 meters. So 2 meters is d. Now once I know the d, I'll be able to find the r pretty easily from this triangle. So from the triangle, I can say if this is r, this is d, angle between them here is 37 degree. So I can write the equation as cos of 37 degree equals to d by r is equals to d divided by cos 37. And what is cos 37? We can write it as 2 divided by cos 37 would be 4 by 5. So I'm able to get this as 5 by 2, that is 2.5 meters. Okay. Now, please understand, those of you who have studied the concept of inclined plane projection, that is projection on inclined plane, you all understand that finding range on the inclined plane is a pretty tricky concept, right? Because the formula that is there, and even the derivation, if you know, the derivation as well as the formula is very tricky to derive. So instead of memorizing the formula, again, instead of memorizing the formula, please understand the concept. It is always easy to find this distance d, because this distance, most of the cases there will be no acceleration itself. So this distance is covered with a constant velocity. So finding this distance would be pretty easy. And once you get that distance, using this triangle concept, I will be able to find out range in a very easy fashion. So please remember this as a trick, okay, for finding the range on an inclined plane. So I hope you have understood. I chose this question mainly for this topic, for all of you to understand how to solve questions of projectile motion on an inclined plane. I'm hoping that you have understood. So we'll stop with this. Okay. Thank you very much.